Okay, so light or optics. Now the first question to the house is, what is light? I know you have done, you treated light way back in GHS. So can somebody tell me what light is, and then the importance of light? What is light? Anybody? Feel free to share what you think about light with us. Anyone to do that? Okay. Okay, Giovanni. What is light?
Light is what helps us to see.
Light is what helps us to see. Michelle, go ahead.
Please, light is a form of energy that enables us to see.
Light is a form of energy that enables us to see. Thank you. Then, who else? Giovanni again. Okay, Alicia.
Light is what our eyes see when light reflects on an object.
Again.
Light is what our eyes see when light.
Go ahead. Light is what our eyes see when it's incident, okay, on our eyes, right? Please, whoever sent this information to me, thank you, but can you please add your name and then the school? I've just received information from another school. Thank you so much, but your name and then, okay, the school. Okay, so all contributions, so far, so good. Let me also give my side of what light is. Light is that part of the electromagnetic waves or spectrum that stimulates vision. Basically, the same as all that you told me, but I am garnishing it with words and adjectives, okay? So light is that part of the electromagnetic waves or spectrum that stimulates vision. Let's go a bit professional. Light is the part of the electromagnetic waves. This is shortened as EM waves. EM waves that stimulates vision or enables us to see. Okay, but there are key concepts we also need to understand. And that is, what is electromagnetic waves? What is electromagnetic waves? Electromagnetic waves are groups or groupings, a grouping of waves, okay, with common characteristics. And what are these common characteristics? One, all electromagnetic waves can be propagated without any media. So EM waves can be propagated without media. Two, all electromagnetic waves travel at the same speed, which is 300 million meters within 1 second. Amazing. within one second, electromagnetic waves could travel a distance of 300 million. So the speed of electromagnetic waves is equal to 3 times 10 to the power 8 meter per second. So these are the key features of EM waves. What waves constitute EM waves? One, we are talking about gamma ray, X-ray, ultraviolet, radiation, and then the concept under discussion, light, visible light. So as you can see, this is part of the electromagnetic waves. Visible light, then infrared, then microwaves, radio wave, and TV signals or TV signal. These are groups, classification or waves that are termed as electromagnetic waves, EM waves. Class, are we okay? So visible light, which we are currently discussing as part of that broader groupings of waves we are calling as electromagnetic waves. So that is the reason for the definition. That light is part of the electromagnetic waves that stimulates vision. Class, give me a minute to take attendance, okay? To take attendance. Right. So thank you so much. Now, let's look at the importance of light. Importance of light. One, I'm sure you talk about the fact that it enables or helps us to see. So I'm writing that, okay, importance of light. Light helps us or enables us to see. What are the other importance of light? Importance of light. Yes, Anita. How is light important to you, Anita? Or you don't derive any benefit from light apart from helping you to see?
I do derive some benefits from it.
Okay, let me give it to me.
It's a form of energy source. It provides energy.
Okay, so light is the source of all forms of energy on earth. So light is the source of all forms of energy on earth. Frank.
Plants need light for photosynthesis.
Plants
Light for photosynthesis.
use light for photosynthesis. Okay. Michelle. Michelle.
Light keeps the earth warm.
Light keeps the earth warm. Keeps the earth. Giovanni.
Is the light in microwaves is used to heat food?
Light in microwaves is used to heat. Okay. But that technology is the in the microwave oven has to do with this microwave. Don't forget, microwave is different from visible light. Okay. All right. I think we've exhausted the common ones we all know. Okay. Meaning that light is really, really important to us. Let's quickly discuss properties of light. Properties of light. Meaning light can exhibit certain key. Martin, is that a question or you want to contribute?
It was supposed to be a contribution.
Okay, yeah, I'll give you the opportunity. Okay, first thing, so don't worry. Light exhibits certain key properties or characteristics. So Martin, give us one of the vast or huge properties of light. Yes.
Light travels in a straight line.
So light travels in a straight line. Yeah, let's. Martin, I'm listening.
Okay. Light is very fast, which it travels with the speed of 3 times 10 to the power 8 meter per second.
So we earlier spoke about the speed of light. Light travels at a speed which is 300 million meters within 1 second. Okay, Frank, your hand is up to travels at a speed of Frank. Elikem.
Sir, please, reflects, light refracts, and light disperses.
Okay. Alikam is saying that light can be reflected, can be refracted, can be dispersed, and can be diffracted. Okay. Please, I'm not writing everything, okay, for the sake of time. You're doing the writing for me. So light can be reflected, refracted, diffracted, dispersed, and interfered. So there are more. Reflection can be reflected, refracted, diffracted, dispersed, interfered, and light can also be polarized. Polarized. Okay, so please note these key properties of light. We are discussing the properties of light. Anobo, what do you have for us concerning properties of light? Oh, we've talked about all that you have. Okay. Now, out of this vast properties of light, we are to go through reflection of light, then refraction. So reflection and refraction of light. So let's look at refraction of light. Class, what is refraction of reflection? What do we mean by reflection of light? When light is said to be reflected, what do we mean? I'm going through the list to call Gideon. What is reflection of light?
Okay, reflection of light means that light is bouncing off an object. It's a shiny or a smooth object.
Gideon, come again.
Reflection of light means that light is bouncing off a smooth or a shiny object.
Okay, so light is bouncing off from a smooth or shiny object by Gideon. Gideon. Jato. Take your time and give me what you are saying.
Reflection of light is the ability of light to bounce off shiny or polished surfaces.
So the ability of light to bounce off from a shiny or reflective surfaces. Okay. Last opinion. Let me have a lady to come in. Oh, the ladies are quiet. Ablina, let me hear from you. Ablina Afo, let me hear from you.
Please, reflection of light occurs when light hits a surface and bounces back.
Okay, so when light bounces from a surface, okay, we are describing that phenomenon as reflection of light. Can we be practical? Let's talk about practical or, yes, natural applications of reflection. Natural applications of this reflection of light. Or everyday applications. Francis, everyday natural applications of reflection of light.
Mirror images.
Come again.
Mirror image.
Mirror imaging. Okay. Or mirror images. That's all.
Yeah, please. Light bouncing off the surface of a watch.
That's all. Come again with your
I
explanation.
said that. You see, sometimes when you sit in class and those people sitting by the windows who wear watch, the lights and the sunlight bounces off it onto the wall sometimes.
Okay. More views. Angela.
So lights bouncing off the surface of water.
Light bouncing off the surface of water. Okay. Yes. Abinema Anobo. Or Gideon is ready. Okay, Gideon. Hello, Gideon.
Principle is used in Facebook.
Gideon, your line is breaking.
This principle is used in periscopes.
I want us to be. I get you, but I want us to be practical, as in how reflection occurs around us before we look at how it is used in devices and all that. Okay. Okay. Michelle.
The moon reflecting sunlight on the earth to the earth.
Good. So the moon reflects light from the sun. Okay. So moon isn't a source of light. The sun is a source of light. The candle, okay, when lighted, is a source of light, even matchstick. But the moon isn't a source of light, but because of its shiny surface, it reflects light from the sun. Okay, then, just as some of you said, formation of images by the mirror. And the mirror is also such that when you cast a beam of light from a torch to it, it will reflect and then bounce it onto a wall. Okay, then formation of rainbow is partly due to reflection of light. Formation of rainbow is partly due to reflection of light. Then light on the surface of the earth by itself is also due to reflection. The major source of light on earth is actually from the sun. So when the sun beams off during the sunrise, the rays or the beam of light from the sun incident on the varied nature of materials on the surface of the earth, and it gets reflected. And that is how come no matter where you hide during the day, light could still reach you. Okay, so these are some of the practical applications of reflection. Gideon, your hand is still up.
Yeah, please, can you go back to the previous slide?
Okay, if you are writing, please quickly do that so we can move on. Oh, meaning I jumped. Okay.
Thank you.
Are you done? All right. Now let's look at types of reflection. So we've described, or yes, we've explained what reflection is about. Types of reflection. And then we'll look at conditions, or yes, conditions necessary for reflection of light to occur. There are two main types of reflection. We have what we call regular or specular reflection, and we also have irregular or diffused or scattered reflection. Irregular, diffuse, or scattered reflection. Before we go into each one of these two types, let's look at laws of reflection. Laws of reflection. Or let's first look at conditions for reflection. What situation must prevail? Conditions for reflection of light. For reflection of light to occur and be appreciated, one key factor which will determine the extent of reflection is the nature of the material. The nature of the material. The surface on which light is being incidented. Is it solid? Is it liquid or gaseous? Solids tend to reflect light better than liquids and then gases. So the nature of the material determines the extent of reflection. And then 2, the nature of the surface. The nature of the surface. Here, the question is that is the surface of interaction rough or smooth? If it's smooth, then reflection would take place better than when it is rough. So these are the 2 main conditions necessary for reflection of light to occur. Okay. So the nature of the material, and then the nature of the surface. The nature of the surface of the material. Okay. Now, laws of reflection. Before we look at laws, I'm not actually going through this systematically because I know you have done some other areas. So I'll just bring your attention to that and then we move on. A ray of light is represented by just a line with an arrow in the middle, meaning that when you are indicating a ray of light, and then you draw just a straight line without an arrow, ladies and gentlemen, you are wrong. So this is how we represent light, a ray of light coming from a source. Now, if you want to, we have what we call rays of light, which in other words is termed as beam of light. So two or more rays constitute beam of light. So we have this as beam of light or rays. So this in particular is parallel beam. Then we can also have convergent or divergent beam. So this is convergent beam of light, meaning all the rays are converging at a common point. Then diverging, all the rays must come from a common point and then they disperse. Okay. So this is a common point. And then, all right. So I've also skipped certain areas of light. I'll put those together because they are readable, and then I'll put those together and then send it to you because they are readable stuffs which you can easily understand, so that we can tackle the ugly-headed ones. All right, so these are the conditions of light. So let's then look at laws of reflection. Laws of reflection. This, I'm sure, was also treated in JHS. Okay, so if this is a surface, it can be rough or can be smooth. Let's assume this is a smooth surface. Example, mirror. So here, this side, the ciliated parts remain the coated or silvered surface. And then this side becomes the reflecting surface. Light is always incidented at the reflected or reflecting surface. Now the first law says that if you have a surface and then you incident light, let's pick a ray, just a ray of light onto the surface. This point therefore becomes the point of incidence. Once you have the point of incidence, draw an imaginary line which is normal to the surface. An imaginary line which is normal to the surface. The word normal means perpendicular. So this point therefore becomes the point of incidence. The point of incidence. This perpendicular line is the normal. once you incident a ray onto the surface, of course, it must bounce off or reflect. And then the reflection must be such that once we have a smooth surface, well-polished surface, then we expect the angle of incidence, which is the angle between the normal and then the incident ray, to be equal to the angle between the normal and the incident reflected ray. And that is the angle of reflection. Don't forget, both angle of incidence and angle of reflection are all measured from the normal. Okay, so we define the angle of incidence as the angle between the incident ray and then, or the normal and the incident ray, and then the angle of reflection is equally the angle between the normal and the reflected ray. Okay, so the first law of reflection says that the incident ray, this is the incident ray, and then there's the reflected ray. The reflected ray always bounces off from the surface. The incident ray, the normal at the point of incident, and the reflected ray all lie in the same plane. They all lie in the same plane. Incident ray, the normal at the point of incident, and the reflected ray all lie in the same plane. Then 2, the angle of incidence is equal to the angle of reflection. This loss of reflection will be tested in school. In school, you conduct simple mirror experiment to confirm the angle of this loss of reflection. Okay, so please take note of. I'm sure, I think this is also a concept in JHS about loss of reflection. Now let's go into these laws of reflection very well and look at mathematical applications that can be treated. Please, if you have any question, you quickly ask. There's our mirror. Please note also that the same laws can be derived when the surface is irregular. Example, the surface of walls. But after laws of reflection, we'll go through types of reflection. Let's assume this is the surface of even a sheet of paper. A sheet of paper isn't so smooth as a mirror. Okay, please let me quickly add. Take attendance again. I have seen other students, else your parents may think you did not show up. Gideon,
Yes.
I'm just reading your message. Is it that slide you talked about, or there's another one? Okay.
No, please repeat us.
Okay. So this is a rough surface. It can be a sheet of paper, a wall, or whatever. Okay. Okay. Okay, so whether the surface is rough or smooth, we can still have the laws of reflection being obeyed. Okay, so this is the incident ray. If you draw a normal to the point of incidence, we can still have this is the normal. The light will reflect. It will reflect and then still obey the laws. That's incident ray, normal at the point of incident, and the reflected ray all lie in the same plane. And we'll still have this equal to this. So whether the surface is smooth or rough, yes, this will still happen. But you know, whenever light beam incident on a wall, rough wall, or on the ground, you don't see reflection. We'll talk about why. But when light incident on the surface of well-polished floors, well-polished walls, the surface of very calmed water, you see reflection. Okay, so we'll go through it and then look at reasons that account for this. Why is it that reflection occurs on well-polished smoothing surfaces and walls, very calm surface of waters, but reflection, hardly can you see your image on the ground. But when that same ground, okay, is well polished, you can see your image on the ground. Why? We'll look at all that, okay? All right. Now, let's go into reflection a bit. Once we've treated laws of reflection, this is a normal perpendicular to the surface of a mirror. Light incident from one side, and then light is also reflected. The laws must be obeyed. Incident reflected. So this is I. This is also R. From the laws, one, I is equal to R. So if I is equal to 30, what must be equal to R? Class, if I is equal to 30, what must be the value of R? 30. Also 30, because angle of incidence is equal to the angle of reflection. Ablina, Okay. I'm recording the video, so I'll send it to you. Okay. And so we can say that if this is I, then instead of writing R, I can also say that this is I. Equally, if the angle of incidence is R, then I can also argue that this is R. Okay, this is because I is equal to R. So take note. So I, this is the normal, which is always perpendicular to the surface. Now, how do we call this angle? The angle from the incident ray to the surface of interaction, or the mirror. What name do we give to that angle? Anybody to help? Anybody? The angle between the incident ray and then the mirror. Oh, Nicole.
It's a glancing angle.
Thank you. This is the glancing angle. So this is theta. So let's define where I is equal to the angle of incidence. R is the angle of reflection. Then theta is a glancing angle. Now we also want to determine the angle of deviation. Angle of deviation. What do we mean by the angle of deviation? Look at this ray. The ray ideally is supposed to travel this or go through this straight line. It's supposed to go this. But it never happened. Why? It did not happen because of its interaction with the surface. The surface is reflective, meaning that because one side is coated, it cannot just pass through. But because due to the coating, mirrors, I can 100% reflect light. That is why at the mention of reflection, all mirrors actually bow. Okay, so this is your original part, but because of how the surface is coated, you cannot reflect. Your path is changed from this to this direction. That is why we are referring to this as the reflected ray. So if we want to determine how wide or how much is the ray deviated, how much has its path been changed? It was going this way, but it's been changed to this direction. So this wider angle becomes the angle of deviation, which I'm representing by sigma. Class, are you okay with me? Are you following?
Yes, please.
Oh, Frank. Frank is asking, say, how would light reflect on a transparent material? Okay, so Frank, what happens is that no matter the surface, when light incidents on a material, part of the light will be reflected, part of it will be refracted. Even wood, when you incident light on wood, very small part of it is reflected, but the greater part is absorbed. That is why you wouldn't see light passing through wood. It's opaque. So the light is trapped within the material. So whether the light is, the material is liquid, gas, part of it will be reflected. But if the material is not transparent material, and we know what a transparent material is, transparent material would readily allow light to pass through it. If it's not a transparent material, okay, the greater chunk of it is absorbed. And that is what will happen in did you say trans? Yes, transparent material. So small parts will be in transparent material, the greater parts or parts of light will pass through. And that is what happens when we have glass prism. But only small percentage will be reflected. Frank, are you okay? And somebody is said, please, how about if light, I'm not getting that part well. Okay. Sir, please, how about if light reflects on a lens? You see, lens, glass prisms refract light. They only reflect small, and they could do so because they are transparent material. For transparent materials, light can easily pass through it, meaning only a small part of it will be reflected. We'll go through all that, prisms and then lenses. So more will be said about it. Frank and Morris, please, are you okay?
Yes, sir.
All right. So the angle, we want to determine how much is the light deviated. How can you help me determine the value of or expression for alpha, the angle of deviation? Please just look at it. Let me give you a trick. This whole angle here on the surface of the mirror constitutes an angle of what? What is this total angle?
180 degrees.
180 degrees. So we are looking for alpha, which is alpha is the angle of deviation. How do we determine that? Just 2 minutes to engage your books, your brain to, respond to me. Just 1-2 minutes. I'll call any one of you at random to share what you have with us. Hey, IMC, what's your name? IMC, International Monetary Company.
Please, my name is Steven.
Okay. Be coming with your full name, okay?
Okay.
All right. Are we through? Stephen, can you share with us what you had? Or you are not done?
No, please.
Okay. Yato? And how far? Priscilla? Priscilla, an expression for the angle of deviation. Okay, Saki.
There, please, is 180 minus the angle of incidence and the angle of reflection.
So, Saki is given 180 minus I plus R. Is that what you are saying?
Yes, sir.
Elikem.
Sir,
Mm-hmm.
I wanted to say I had 90.
Come again.
I wanted to say I had 90.
90.
Yeah.
Okay. A lady to share with us what Ella Davis. Ella,
Hello, sir.
how far have you gone?
Sir, please, I agree with Giovanni.
Giovanni, okay. Michelle, what's your answer?
Please, I also agree with Giovanni.
Hey, this agree thing. I will not agree. Oh. I'll agree to disagree. Oh. Okay. Augustine is also giving us 180 minus 2i. All right. I think I'll give this one. Maybe let me give you 1 for the effort. I'll give this one 4 on 5. Then I'll give this one 5 on 5. For this one, I don't know how you managed to get 90. This one, yes, the whole angle constitutes 180. So clearly, to get this, you must subtract this from 180. So that is why 180 minus this. Zaki.
So please, but what I did was the same as the 5/5.
Oh yes, I know. I know. I'm coming to it. Okay, so to get this, obviously you must subtract this one. You must subtract this whole angle from 180. Okay. Now, the difference between 4 on 5 and 5 on 5 is that the 5 on 5 could remember that I said angle of incidence is equal to angle of reflection. So if the angle of incidence is I, then this would also be I. So it's more or less like I plus I. So just subtract I 2 times I plus I from 180. So Saki, what you overlooked was this. Okay. That is why I penalize you small by taking 1. So the angle of deviation for mirrors is equal to 180 minus 2i or 180 minus 2r. It can be 2i or 2r. Are you okay? So let's take note. I'm going to give you a question. A mirror, light, or a ray of light, incidents on a mirror at, I'm modifying the question. Hold on. I just want to modify the question. Let me answer this. So how come water is transparent, but it is able to reflect light? That's what I'm saying. The moment the light hits the surface, part of the incident light will be bounced off from the surface. That is reflected. But because water is transparent, okay, greater parts of it, of the incident light will pass through it. So only a small part will be reflected, but about 99% will be absorbed in the water when it is transparent. Hey, Michael. Okay, so the angle between the incident ray and then the reflected ray is 70 degrees. The angle between incident ray and reflected ray is 70 degrees. One, determine one angle of incidence. So determine one angle of incidence two, glancing angle. And three, angle of deviation. So I think 5 minutes you must do this. 5 minutes.
Sir, is what's written in green part of the question?
No. Let me clear it. The actual question is the red one. Okay, Frank, when we are solving, I'll discuss it again with you. Okay, Augustine has forwarded his answer. So this time around, I would, when your time elapses, I'll solve it. So you mark whatever you're able to put down. Okay. You have 2 minutes to end. Let's be a bit snappy, because this time around we are using 1 hour 30 minutes. The lesson is to end at 11:15. Okay, so let's look at it. We are told that the angle between the incident and the reflected ray is 70. And it means this angle, this is the incident, this is the reflected, and this angle is equal to 70 degrees. We have to determine one, the angle of incidence. Okay. Now, the angle of incidence will be equal to R. Okay. It means that I plus R is 70. And because I is equal to R, we can also say that this is 2 times I. I plus R is equal to 2I. So 2I is equal to 70. Therefore, we have I giving us 35 degrees. So the angle of incidence is equal to 35 degrees. Glancing angle. Glancing angle is the angle between the incident ray and the mirror. So if this is 35, class, the normal is always perpendicular to the surface. So it also implies that the angle of incidence plus the glancing angle theta is equal to 90. The angle of incidence plus the glancing angle is equal to 90. We can also argue it from this side, that the angle of reflection plus the glancing angle is also 90. So if I is 35, then the glancing angle will be 90 minus 35. And class, what is 90 minus 35?
55.
That's 55 degrees. Okay. Now to the angle of deviation. So what did I say about the angle of deviation? The ray is, its ideal path is to go this straight. It's to go this straight line. But upon its interaction with the mirror, its path is changed. Instead of coming straight down here, it couldn't. It's incident on the mirror and then bounces off here. So if we want to determine how much is the ray, is a part of the ray deviated, okay, this is your path. This is supposed to be your path, but you find yourself here instead. So how much have you been deviated? That is to determine this angle. So this is the angle of deviation. So if I want this angle, since this total angle on the of the ray constitutes an angle of 180, an angle on a straight line, meaning to determine this large angle, I should first know this and then subtract this from 180. This is equal to 2i. So if I subtract this angle from 180, I'll be able to get this. Meaning that the angle of deviation plus 2i is equal to 180 degree. Therefore, angle of deviation is equal to 180 minus 2i. I have the angle of incidence, 35. So the angle of deviation will be 180 degree minus 2 times 35. And 2 times 35 is 70. So 180 minus 70 is equal to 110 degree. Okay, so Frank, that's how we got it. Yes, Bashira, I plus R is equal to 70. So let me see by hands those of you who scored everything. If you got everything correct, let me see you. Show by hands. Okay, I have 2. Okay, 5 hands, 6, 7, 8. Thank you. We are doing great. Yes. Thank you so much. Next time I'll increase the level of difficulty of the question. Yeah. So let's then quickly look at types of reflection. Types of reflection. As I said, we have regular reflection and irregular reflection. Regular reflection occurs on the surface of a mirror, well-polished surfaces, on the surface of well-polished floors, walls, then on the surface of calmed waters. Calmed waters, meaning if the water surface is not calm, we can't have that. And how does it happen? Let's take this to be the surface of the mirror or well-polished surface, well-polished wall, calmed surface or water surface. And how does it happen? Here we have beam of rays, parallel beam of rays incidenting on the surface. Now, because of the even nature of the surface, if you pick any individual ray and consider the point of incidence, for each one of them, the angle of incidence is the same. So what I'm basically drawing is the normal to each one of them. So because of the even nature of the surface, angle of incidence to all of them, 1, 2, 3 rays, the same. And so the angle of reflection is also the same. Because of the even nature of the surface. I have to adjust this a little. So, under regular reflection, because of the even nature of the surface, angle of incidence, angle of reflection, the same for all of them. So the incident beam is in that regular or orderly manner, so is the reflected beam as well. Okay, the incident beam is in that orderly or regular manner, and so is the reflected beam. And whenever regular reflection occurs, there is the formation of virtual image. So regular reflection brings about the formation of virtual images. That is why when you are walking on a well-polished floor, you can see your image. When you are walking beside water, whose surface is so calm, you can see the image of yourself, you can see the image of trees around. So regular reflection brings about the formation of virtual images. Then what about its friend, irregular or diffuse? So this is well polished or floors, polished floors, mirror, surface of calmed waters and all that. This surface is irregular. It can be paper. It can be the ground or the earth surface. It can be rough wall. Disturbed surface of water. Now what happens here? Rays incidents on the surface in that orderly manner. However, due to the uneven nature of the surface, the angle of incidence of each one of them is different. The angle of incidence of each one of them is different due to the irregular nature of the surface. So the reflected beam are scattered. So orderly incident beam, but scattered or irregular reflected beam. And this is what happens in irregular reflection. Class, are you there? No one is even coughing. So this is what happens in irregular or diffuse reflection. Now, it's also, I said that regular reflection brings about formation of virtual images. Here, there isn't formation of image, but this irregular reflection also ensures equitable or evenly distribution of heat and light from the sun. Okay, this also has its importance, and one of it is that it ensures evenly or equitable distribution of light and heat from the sun. Don't forget, on the surface of the earth, we have objects of different cross-sectional areas. So irregular or scattered or diffuse reflection ensures evenly / equal distribution of lights and heat from the sun. That is why no matter where you hide during the day, light will still reach you. You can keep yourself in a room, close yourself. If there is small opening, light will still reach you. You wouldn't find yourself in an absolute dark place. Okay. So this is because of the uneven cross-sectional area of objects on this. On the surface of the earth, we have plants, we have rocks, trees, plants, we have human beings, we have cars. So when light from the sun incidents on this, it throws it in varied directions and then ensures that the light from the sun is equally distributed. Okay. Hey, we are to close at 11:15. Is that true?
Yes, please.
Hey, oh, interesting. It's similar to somebody who is eating and is not satisfied, but I still need to get satisfied. So this is where we draw the curtains on today's meeting. Ladies and gentlemen, we're going to continue it tomorrow, okay? All right.
Okay.
Have a nice day and then continue doing the good work as we all expect of you. We'll continue tomorrow. Bye-bye to each one of you.
Bye.
All right.
Bye.
Bye.
Well, bye-bye.
Bye.
Okay. Okay, Vanessa, I said that regular reflection brings about formation of virtual images. That is why if you happen to walk on the surface on a well-polished surface, you have your image. If you look at yourself in a mirror, you see your image. If you walk beside water bodies and the water surface is calm, you see your image. So regular reflection brings about formation of virtual images. Okay. irregular reflection does not form images, but in irregular reflection, it also ensures equally or evenly distribution of light and heat from the sun. I hope you're okay. All right. Okay, bye-bye then.